Hello and welcome to today's lesson on vectors and scalars. Our learning objectives are to explain the difference between a scalar and a vector, the difference between distance and displacement, and the difference between speed and velocity. For this first activity, you're going to need to draw out a treasure hunt on a piece of paper. Imagine the top of the paper is north, and you're going to start in the centre of the paper, draw 3 centimetres north, then 3 centimetres west, then south 5 centimetres, west another 4 centimetres, and then finally 2 more centimetres north. Okay, so if you've got paper to hand, that's great. Otherwise, pause the video, go find yourself some paper, ideally squared paper, and then sketch out these 5 different steps on the map. When you've done that, press play again. Having drawn your route on the treasure map, I'd now like you to work out how far you've actually travelled. Pause the video now if you need to while you work it out. You should come up with a distance of 17 centimetres. Although you've travelled 17 centimetres, how far are you now from where you originally started? You can measure this with a ruler. If you've drawn it correctly, you should find that your start position was 7 centimetres west of your finish position. The distance between 2 points isn't always the same thing as the distance that you need to travel to go from one to the other. The distance that you actually travel is likely to be longer because you have to go round objects or follow a set path. The distance from one point to another without changing direction is called displacement. Displacement has both direction and magnitude. It's what's called a vector, and all vectors have both direction and magnitude. If a quantity only has a magnitude or a size, it's called a scalar quantity, such as mass or speed. In a car, you may have both a speedometer and a sat-nav. Now, the speedometer focuses purely on the size of the speed. It is looking at a scalar quantity. In contrast, the sat-nav will focus on the direction as well in order to make sure you get to where you're going. And so this looks at a vector quantity, velocity. Here we have a list of quantities, and I'd like you to try and sort them out into a column of vectors and a column of scalars. Pause the video now and in your books write down where you think they would fit. And here's the correct answer. Both displacement and velocity have direction and magnitude and are vectors, along with acceleration. Weight has a direction. If you think about it, weight always acts downwards, and forces always work in a direction. In contrast, we've got distance and speed, both scalars. Temperature is a scalar. It doesn't matter which direction you hold a thermometer, it's still going to read the same temperature. And again, mass and time are both considered scalar quantities. I'd like you now to write an explanation in your books for what a scalar and a vector quantity is and include an example of each one. Pause the video now while you do that. We often use arrows to represent vectors. The direction of the arrow shows you the direction that the vector is working in, and the size of the arrow gives you an indication of the size or the magnitude of the vector. When we're adding vectors, we need to take into account their direction as well as their magnitude. So if both vectors are working in the same direction, so here we have 2 velocities of 20 meters per second, if they're in the same direction, they add together to make a velocity of 40 meters per second. However, if they're going in opposite directions, then they would cancel each other out. So the one moving to the right would be a positive value, but the one moving to the left would be considered a negative value for a total velocity of 0 meters per second. Here we have 5 practice questions, and I'd like you to do these in your books. While you're working through them, just pause the video and see if you can answer all 5 correctly. Just remember, you need to take into account the direction that the vectors are working in. So here are our answers. First of all, we've got seconds, which is a scalar quantity. 20 plus 25 is very simple, 45 seconds. Now we have to add 30 meters to the east and 15 meters to the west. I've taken west as a negative value, So 30 metres minus 15 metres would give us 15 metres to the east. Then we've got a speed of 55 metres per second minus 55 metres per second, giving us a total speed of 0 metres per second. And 20 newtons to the right and 40 newtons to the left would give us a force of 20 newtons to the left. For the final one, 20 metres per second and minus 50 metres per second gives us minus 30 metres per second. Now for a little puzzle. How could 4 plus 3 end up equaling 5? Have a think about it, pause the video if you want to, and then we'll move on. If you were to walk 4 metres to the east and then 3 metres north, what would your final displacement be, and how could you work it out? This image may give you a bit of a clue. You should be familiar with Pythagoras' theorem already from your maths lessons. A squared plus b squared equals c squared. And we can use this to work out resultant vectors from two vectors working at right angles. In our example, sides A and B are 4 metres and 3 metres. 4 squared plus 3 squared is 16 plus 9, which is 25, and the square root of 25 is 5 metres. So our final displacement would be 5 metres. This should hopefully explain how, with vector addition, 4 plus 3 can equal 5. In this question we have a hiker who walks 5 metres to the west and then 8 metres north. What's the magnitude of his displacement, the size of x? Pause the video now and try and work it out. The displacement should be 9.1 metres to 1 decimal place. In this question, a boat is travelling forward at 9 metres per second, but the river is flowing at 6 metres per second to the left. What is the total speed? You should get an answer of 10.8 metres per second to 1 decimal place. A climber is pulled by 2 ropes at 90 degrees to each other. One rope is pulling with a force of 15 newtons, the other rope is pulling with a force of 11 newtons. What would the resultant force on the climber be? Pause the video again while you work it out. You should find that gives you an answer of 18.6 newtons. And for our final question, a runner races around a circular track at a constant speed and is very proud of their time. A friend points out that their average velocity is 0, so why bother? In your books, I'd like you to discuss whether it is true and explain your answer. Once you've done that, that brings us to the end of today's lesson. Thank you very much, and I hope you found it useful.